Good morning, students. This side Jitender Singh, newly appointed your physics PGT, and this session in St. John's International School, we will be there to just share each other's information. But yes, right this time, it's only the way which we are having to interact is this medium, which is your YouTube and this video medium. We can say simply it's a virtual way where we can interact only. Yes, you know why it is happened. It is well known by you all that it's due to one virus which spread worldwide, and right now everybody in every corner of this world, people are just worried about and afraid of even. But yes, you should not afraid. Don't get in panic because government has already given the guidelines. You know this virus size is bit bigger. So if you use mask, it could be stopped easily. But doesn't mean to wear all the time in home. If you go outside, you should wear it. Be yourself in your home. Don't interact with others. Means interact doesn't mean not to talk. But yes, if you are going to talk with somebody, keep a distance of 1 meter at least, so that if somebody is already infected, should his virus should not reach to you easily. And yes, if you are going outside, wear the mask definitely. In home, keep yourself with your family, so that this type of interacted people, if they are outside, so they are outside, you are not going to interact with them. Yes, wash your hands even after frequently you should go for, means 20 seconds is required at least. If you don't have water over there, maybe in any situation, maybe you have less quantity of the water, or you don't want to waste water, so sanitizer is one of the alternative for this. But doesn't mean you should use a sanitizer if you do have water and soap. So better, we are in India, so we have ample amount of water, but you should use it properly. So now it was about this holidays, so better keep yourself safe. So we are going for this chapter which is of 11th class, chapter 1, physical world. And in next 10 to 15 minutes, don't go here and there, just concentrate for the few minutes. Yes, if you have any problem, read this one, rewind it one, check out. If there is any problem, just underline and just take care and give me the question. So just tell me that part so I can go for a bit more description afterwards. So yes, without wasting time, let me go for chapter 1, physical world. Here we are going to talk about all the physical thing which is present in this world, and we'll discuss about. So what is there in this chapter? It contents are there 5 contents. So first is what is physics. So we'll discuss here what's the physics. Second, its scope, how far its scope is. And next, third is excitement of physics, means what physics has done in our life. Has it added something? Has it made something fabulous? Has it increased our living standard or not? We'll see it in third point. Now, fourth is a fundamental force in nature. In this, we'll check about what are the basic forces or fundamental forces which governs this nature. Like we are being governed by the our constitution, because whatever they have written, we are getting that right or we are following it properly. The same when you're going to school, you have been given some guideline that you are following. Next is about nature of physical law. Then after we'll see about what is the nature and characteristic or quality of physical laws. So let me go for next. So here, what is physics? In simple terms, it's a study of nature and natural phenomena happen around us. So let me see what are the example for. So first is repetition of day and night. After 24 hours it is happening or repeating every day. Cycle of season, yes, it is repeating after 1 year again. Then eclipse, it could be solar or lunar eclipse. then tide, high tide and low tide, and the last, the rainbow. And even more, this is an example which is happening in the real world or you have seen it. So to know about and the reason, these all mentioned this physics. So let me go for a bit about, you have just completed your 10th. So yes, not a 10th completed because one paper is still pending, but yes, I hope so that will be done by you easily. It's not a big deal for you. So in 10th, you was having the solar or lunar eclipse, then tide, high tide and low tide, and the last, the rainbow. And even more, this is an example which is happening in the real world or you have seen it. So to know about and the reason, these all mentioned this physics. So let me go for a bit about, you have just completed your 10th. So yes, not a 10th completed because one paper is still pending, but yes, I hope so that will be done by you easily. It's not a big deal for you. So in 10th, you was having science. If I just divide into three, so that the main is physics, chemistry, and bio. So let me go for the main word is a science. So science word, it is originated from the Latin word, we call it scientia. Its meaning to know. In Sanskrit, even this word has been given as a vijnana, and in Arabic, it is used by this word ilm. These all three is having same meaning, to know. So if I go for the definition, so science is a systematic attempt to understand the natural phenomena in depth as possible and use the knowledge to predict, modify, and control phenomena. If you go the simply, so it's a simple steps, systematic way we are going to understand the natural phenomena which is happening near around us and gathering that information as deep as possible and use that knowledge information to predict about when it is happening again and how does it happen, and modify or later on just try to control this phenomena for our benefits. Now next, what the method used by the science? So let me see the scientific method. If we see in this, in scientific method, some example let me show you. If you see that twinkling star or apple falls down or a rainbow, it is the first thing, that's the observation that comes in first. It could be the observation, could be the problem, like coronavirus, it is a problem right now, so we have observed this is happening. So what we are doing, we are doing the control experiment in the lab, and afterwards we are collecting data. If the data is coming in numeric form, so we are taking in quantitative form, and qualitative form, it is valid or invalid cases, or we are using mathematical model or tools to solve it if it is a data type, and verifying it is right or wrong. If I go according to this diagram, just see the numeric form, so we are taking in qualitative form, quantitative form, and qualitative form, it is valid or invalid cases, or we are using mathematical model or tools to solve it if it is a data type, and verifying it is right or wrong. If I go according to this diagram, just see this. First, the problem which is coming, either it is a problem or observation, then we just going in a lab collecting more information about it, and after collecting information in lab, what we are doing with, we are making one hypothesis. Hypothesis means we are just assuming something. So on this assumption, we are doing some test. So after those tests, we are collecting the data, and after analyzing, we are coming on one conclusion. Now it could be two things. Maybe your hypothesis, what we have assumed, it is right. So we are going back for the repetition to test this hypothesis again, analyzing data and conclusion. We're coming on this conclusion. If it is happening again with the same way, it means our hypothesis is right. But yes, by the in any case, like whatever conclusion we got at the last, but doesn't match with the hypothesis, So we go back to there to form the hypothesis to get the assumption what could be the things, what could be that thing. So on the basis of that hypothesis we are going to test again, we are analyzing, we are drawing out conclusion. If conclusion is not according to the hypothesis, we are going for one more five for modifying the hypothesis. We are going to change this assumption which we have made in this hypothesis, and that repeats this cycle until this cycle convert into sub hypothesis supported. If it is supported, so we are going for the confirmation again, and this way the scientific method works. Now scope of physics means how far the physics has gone. So basically there is three domain of interest of the physics, where micro means very small, microscopic, second is macroscopic, and third is mesoscopic. Mesoscopic is between the micro and macro. So microscopic, what comes in the microscopic? In the microscopic domain, atom, molecules, and nucleus comes, where we are going to study about these three. And macroscopic, there are the phenomena in labs, terrestrial or astronomical scales, which is very big. But macroscopic is between the micro and macro. So microscopic, what comes in the microscopic? In a microscopic domain, atom, molecules, and nucleus comes, where we are going to study about these three. And macroscopic, there are the phenomena in labs, terrestrial or astronomical scales, which is very big. But mesoscopic, it intermediate between microscopic and mesoscopic physics. Now let me go for the range for the three things: mass, length, and time. How far we have reached here. If I go for the mass, it is uh, if I go for least, so it is 10 to the power minus 30 to 10 to the power 55 kg we can measure right now. And length, if I go for, so it's more than 10 to the power 40 meter we can measure. And if I talk about the time, so it is 10 to the power minus 22 to 10 to the power 18 second, this much we can measure. Now let me go for the branches of physics. But yes, before I should go for the branches of physics, I should tell you some class about some classical physics. So mechanics, thermodynamics, optics, and electromagnetism. These four comes from classical physics. Initially, this was so. After these four, even more added up. So these three comes in modern physics. So let me go for the first mechanics. Here we talk about motion and its causes, which you have read in your ninth class, motion. Thermodynamics, it's all about heat and temperature system. Whatever system is there, if there's a heat and temperature, whatever change is happening, we all study in this thermodynamics. If it is optics, we are talking about the behavior of light. And electromagnetism, here we are talking about electricity, magnetism, and EM waves. Now newly three things are added up, like nuclear physics, where we are talking about the structure of nucleus, energy associated with the nuclear changes. Now in atomic physics, the structure of atom, energy associated with the atomic changes. Vibration and waves, it is all about the periodic motion which is created by the wave. Now so these three are added up later, but for first four, these four, mechanics, thermodynamics, optics, and electromagnetism, okay, they were the part of classical physics. Now excitement in physics means what physics has done, we and added up later, but for first four, these four, mechanics, thermodynamics, optics, and electromagnetism, okay, they were the part of classical physics. Now excitement in physics means what physics has done which make us excited. So if I see the old time, so there was a button we just pushed to make it on and off, but now after that time wired remote came up, but now we are using remoteless wire, means it is wireless or even remoteless. On the basis of the hand gesture we can shift the pointer of smart TVs easily. Now, postman to mail. Earlier time, the postman comes to gives us message in a letter, but afterwards, a mail we were using. Now we are using voice. We are just recording the voice or sending up. Then video messages and even live broadcast is happening nowadays, which is all done by this physics. Okay, good. Now the third point, wired phone to the wireless phone and mobile. Earlier, the wired phone connected, the wire was there, but now there is a wireless phone we are using mobiles simply and smartphones. Yes, definitely. Fossil age to the electric age and now electromagnetic. Initially we were using coal, petroleum, now electric we are just shifting, and after some time definitely now electromagnetic uh, rails we are using where the magnet is being used, electromagnetic activity is being used to just send commuters from one place to another place. If I go for one addition I have done from my side, like if I go for the revolution which has happened, just see it's 5 points I have mentioned. Like first is mechanical, where the factories came in existence in 70s, earlier 70s, 1670s, their factories came in existence where man was involved in mechanical process. If I go for afterwards, electricity came in existence and bulb came in existence and nighttime become bright for us, for the humans. Now third is computer, ICs and automobiles. Computer and automobiles came and added up one more revolutionary part to the human life. And afterwards, the globalization, interconnectivity of the computer in all over the world. And the cyber interconnectivity had happened after the 3.5 to 4, where it seems like a global village afterwards. Computer and automobiles came and added up one more revolutionary part to the human life. And afterwards, the globalization, interconnectivity of the computer in all over the world. And the cyber interconnectivity had happened after the 3.5 to 4, where it seems like a global village afterwards. But now robotics is coming in, so artificial intelligence will be quite impressive in next decade. So let us see what happens in robotics and artificial intelligence. Now, scope of physics. Now, if I see for this one, two basic questions of the physics are there only. Actually, what happened? Lot many theories and laws came in existence. So our main concentration is there to make it unify. Unification means, like if I giving the example, flow of water, revolution of Earth, revolution of Moon. So if it is happening, means some if it is happening, so what is the main cause behind? We just merge up into one cause behind it. So the single cause is gravitational force. So we are unifying all the things. Whatever is happening, we're trying to unifying it. We are going for just merging down into simpler and even less number of laws, so that it will be easy for us to drive later on. So unification, we are just unifying and reducing the number of activities which is happening by some basic force. Like here, gravitation force is responsible for all three. Now reduction means step, like second quest is about the steps to get the result easily. Like if something has happened, so first we'll decide which force is responsible for, and then we'll go for the steps which includes that force. So unifying, reducing the loss, and second, unifying the reducing law, reducing and reducing steps to just justify. Now, fundamental force in nature. Force, actually, what is it? Force is a push and pull that cause an object to change a state, motion, or rest, or shape. Type of forces, here the two forces are there, fundamental and derived. Fundamental is non-contact force, and derived force are the contact force. Like, let me give the example. They are basically originated from fundamental forces like friction, spring, and muscular forces, etc. Fundamental force is the basic or natural existing. First is gravitational force. Second is electromagnetic force, where electricity and magnetism both are involved. Third, strong nuclear force, where we are talking about nucleus where the proton and neutron are bind very tightly by this force. And weak nuclear force like nuclear decay or I can say radioactivity, which is responsible for just breaking down big nucleus into the small pieces. Now, first, gravitation force. Let me go for a bit description about the gravitation force. It is universal force, and it is between all objects in universe, whatever they are. It is only attraction force between those objects. No repulsion. No medium is required in this force. Weakest force in all. If I see all four forces, this one is the weakest one. Range, its range is infinite, very large range. Now, next is electromagnetic force. Now, in this electromagnetic force, this is the force between charged particles. It could be attractive or it could be repulsive. A repulsion can be happen here. It is a strong force and its limit is infinite. With the third force is strong nuclear force in the nucleus between proton and neutrons, which bind them collectively strongly. It is the strongest force amongst them. And short range, it is a short range force. And weak nuclear force, let's talk about, as you know, radioactivity is happened by this force. Weak force, it is weak one and responsible for radioactive decay, which we have just talked about. Now this diagrammatic representation. Strong forcing forces bind the nucleus like this. That's a strong nuclear force. Now let me say the gravitation. Let me start with the first one. Gravitation, here the sun and one planet is just revolving around the sun, and this is bind by gravitation force. Now second was electromagnetic force, which bind the atom. See, this is the electron which is negatively charged, and in mid there is a nucleus which is somehow the positive, which contains positive charge. And third was strong force, the bind nucleus. Just see these start with the first one. Gravitation, here the sun and one planet is just revolving around the sun, and this is bind by gravitation force. Now second was electromagnetic force, which bind the atom. See, this is the electron which is negatively charged, and in mid there is a nucleus which is somehow the positive, which contains positive charge. And third was strong force, the bind nucleus. Just see these uh, red and green dots where the positive and neutral charges had been shown, which bind these subatomic particles. Now last is about weak force. Here this big atom is going to just distribute into two small particles. Here are radioactive decay. It is being shown like alpha beta decay is happening. Now the last topic is about nature of physical laws. So here is conservation laws. Here the five main conservations are there. Conservation of energy, conservation of mass, conservation of charge, conservation of momentum, linear or angular both, and conservation of parity. Let me go for first. Conservation of energy. In this, one energy change into another form. Just change in the form of the energy, like kinetic to potential, potential to kinetic. Now, conservation of mass, like balancing equation and reaction. You must have seen in chemistry that you have balanced the equation after the reaction. So that shows the conservation of mass. It cannot be made, it cannot be destroyed. So now, conservation of charge. Charge in a system. In a system, charge is always equilibrium. It is conserved ever. Conservation of momentum, linear, angular. It is all the questions related to collision, from head-to-head collision, or maybe from backside is a collision, or maybe fast moving or slow moving collision. All there the conservation of momentum works. Conservation of parity. Here is about a subatomic wave function where it is conserved. Now what we have covered: what is physics, its scope, excitement of physics, fundamental forces in nature, and nature of physical law. Okay, students, this much we have done. It was all about the first chapter, and I'll be sending you a worksheet where you should try to do those questions, and these questions related to my this presentation. So I hope that you will be doing easily. Thank you.